Okay, today we're going to talk about exponents, particularly exponents of 1, 0, or negative exponents. Okay, before we begin our discussion today, let's remember that an exponential expression is something in the form of a sub n, and then when we expand that, it's a multiplied together n times. Also, we have talked about multiplying with exponents, and we found the general rule to be that when we multiply with the same base, we add the exponents. That's why our general rule reads a sub n times a sub m equals a sub m plus n. And with dividing, we saw that with that general rule, when we have the same base, we subtract exponents. So let's first talk about an exponent of 1. If we look at how this comes about there on the left-hand side where we're going to use the rule, then we have a to the 3 minus 2, and then we simplify that and we have a to the first power. And if we look at that on the other side using expansion, and we expand that out and we have a multiplied 3 times divided by a multiplied 2 times, and we cancel a pair of a's there from the numerator and the denominator because they make a 1, then we have just a. So that gives us the rule that a sub 1 is equal to a. And that's a very important one for us to realize that 1 does not have to be written. When we see an a, it really does have an exponent of 1. Any number has an exponent of 1. 3, just the plain old number 3 has an exponent of 1. We just do not have to write that 1. All right, I'm going to let you practice with a few of these here. If you would like to pause now so that you have time to finish those and then come back so that we can check your work. Okay, I guess you're back. We will now look at the answers to these. For 3 to the 19th divided by 3 to the 18th, you're using the rule there. 19 minus 18 is 1, and 3 to the first power is simply 3. In problem number 2, you have 10 to the third divided by 10. Well, that's 10 to the third divided by 10 to the first, and 3 minus 1 is 2, so you have 10 squared. We could simplify that to 100, but for the sake of what we're doing today, I just left everything expressed as an exponential expression. In problem number 3, we have 9 to the 34th times 9. You think of that 9 as 9 to the first power, and then we're going to add that 31 plus 1, and we get 9 to the 35th. Sorry for that interruption. Now, looking at problem number 4, we have x times x. And if you'll think of each of those x's as x to the first power, so we have x to the first times x to the first, and that's a 1 plus 1, so that gives us x squared. I do want to mention here, I have written out every time rewriting those numbers with that first power. You don't necessarily have to do that. If it helps you to do that, you're more than welcome to do it, but it's not a requirement. Like in problem number 4, when you see x times x, and you know that those are ones understood to be there that are just not written, you can jump straight to the x squared part. Now, let's think about an exponent of 0. If we use the rule here, we have a squared divided by a squared. That gives us a to the 2 minus 2, which gives us a to the 0. And on the side using expansion, we have a squared divided by a squared. And if we expand those out, we have a multiplied 2 times divided by a multiplied 2 times, and both of those are going to cancel. Well, when both of those cancel, we have an answer of 1 in that case. So now we can see that a to the 0 is equal to 1. A to the 0 represents dividing something by itself. And we know from past experiences that when we divide a number by itself, the answer is 1. Okay, here are some for you to practice. So if you will pause now so that you have time to complete those, and then come back when you're ready to check your work. Okay, I guess we're back now. So let's look at these, and we have number 1, 5 to the 12th divided by 5 to the 12th. Well, 12 minus 12 is 0, and 5 to the 0, as we just learned, is 1. In the second one, we have x to the 15th divided by x to the 0. 15 minus 0 is 15, so we have x to the 15th power. You could have also thought about that as x to the 15th divided by 1, since x to the 0 is 1, and just left it at x to the 15th that way. Problem number 3, you have 10 to the x divided by 10 to the x. Well, x minus x, no matter what x is still 0. So 10 to the 0 is 1, using that property that we just learned. And x to the 5th divided by x to the 5th, 5 minus 5 is 0, and x to the 0 is 1. Okay, let's look at some negative exponents now. And the first thing we're going to do is look at them with numbers in place as our exponents. I realize our base is a variable, but we're going to look at using a number as our exponent, and then we will move into using variables for our exponents to get a more general rule. So here we have a to the 3rd divided by a to the 5th. That gives us a to the 3 minus 5. And that gives us negative 2, a to the negative 2, because 3 minus 5 is negative 2. And if we look at the side using expansion, we can see that we have a multiplied 3 times in the numerator and a multiplied 5 times in the denominator. So now when we cancel those pairs out, we're left with a's in the denominator, where we have been being left with them in the numerator. And when that happens, then we have a 1 in the numerator, and we can recombine our a's because we have a multiplied 2 times left down there. So we have a squared in the denominator. So now we can see that a to the negative 2 is equal to 1 over a squared. And that'll lead us to our more general rule here on our next slide. In our general rule, we have a to the 0 divided by a to the n. Well, a to the 0 minus n would equal a to the negative n. And on the other side, using expansion, we have a to the 0, which is 1. It's the only way we can expand it. And then we have a to the n, so we have a multiplied n times, which is just gives us 1 over a to the n. So that leads us to the conclusion that a to the negative n equals 1. Sorry for the interruption again. So a to the negative n equals 1 over a to the n. Another way of saying that is that a base raised to a negative exponent is really 1 over that base raised to a positive exponent. And now's your chance to practice using what you've learned about negative exponents. So if you will pause here and then come back when you're ready to check your work. Okay, I guess we're ready now. So we have 5 to the 12th divided by 5 to the 15th. 12 minus 15 is negative 3, so that gives us 5 to the negative 3. And then using what we know about negative exponents, we're going to change that to 1 over 5 to the 3rd. And in problem number 2, we have 3 to the 2nd times 3 to the negative 8. We can go ahead and combine those exponents before we use our rule for negative exponents. And so we have 2 plus negative 8 is negative 6, so we have 3 to the negative 6, which becomes 1 over 3 to the 6th. Now, in problem number 3, we have x to the negative 5 times x to the negative 9. Well, negative 5 plus negative 9 is negative 14, so we have x to the negative 14th, which is 1 over x to the 14th, using what we know about negative exponents. Problem number 4, we have x to the negative 3 divided by x to the negative 2. Well, negative 3 minus negative 2 gives us negative 1. So we have x to the negative 1, which is really 1 over x. And I don't have to write that 1, remember, because we know that x to the first is the same as x. So, thank you. We're going to have a little clicker quiz over this now so that you can see if you've retained what we've learned in here. And if not, then we'll have some extra practice for you. There are several concepts introduced here, so it's a little more difficult than what we've been doing, but you got this. Have a great day.